All right, so yesterday you guys had an assignment, but we finished it in class, right? So now we are just ready to dive right in. That's us doing, diving in. What? We're getting another assignment today. Yeah, that's kind of how I roll. Yeah. Yeah, there's only 8 pages on this thing, so we should be able to. Okay.
Are we doing another chapter class before semester?
I'm going to say yes. Yeah, I'm going to say yes. All right. So somebody over there, maybe it was Taylor, maybe it was Marlena, maybe it was Janessa, maybe it was Sky, asked a good question yesterday. They said, what kind of problems are we going to even do with this stuff? Okay, that was Marlena. Because we're just talking about how different things equal different things. And so today we get to see what these problems really look like. So these are algebraic transformations. So what we're going to do is we're going to start with an expression written in one way, and then we're going to use, I got to get my pointer for students who are absent. Then we're going to use these transformations or whatever that we talked about yesterday to change them into something different. Okay? Are you ready?
Oh wait, do we have to write these down?
No, you don't have to write any of this down. No. Are you ready? Go. All right. So what we're doing today is given a trigonometric expression, we're going to transform it into an equivalent form that is perhaps simpler or more useful. And I know that this is something that is going to be like not for a lot of you, because really where you would use this is in calculus class, and I know some of you that's not the destination that you're headed to, but you will notice that the word on the cover of your book is pre-calculus, so mostly this is oriented at preparing students for that course. So if that's not a direction you're headed, I apologize in advance, but it's not going to hurt you. Nope, you're not going to skip it. All right, so let's start with an easy one. Let's transform sine of x times cotangent of x into cosine of x. So I'm starting with sine of x, cotangent of x, and I want to change that into cosine of x, okay? This is a one-stepper. Isn't what cosine divided by sine? Okay, so Danica points out that cotangent is cosine divided by sine. So that means I can rewrite that part as cosine divided by sine. So Danica changed that into that, and then the signs cancel out because one's on the top and one's on the bottom, and you're left with cosine of x, and our work here is finished. Okay? So that's that. Okay, we good there? Okay, that's obviously an uber easy one, just to give you an idea of what this is all about. This is a little bit more challenging. Cosine squared x minus sine squared x, so this doesn't equal 1 because we're subtracting. We want to take that and find a way to change it into 1 minus 2 sine squared of x. Okay, so I have to caution you. Some of these I don't necessarily know how to do right out of the gate, and so some of them we're just going to try something and hope that it works, but we might be wrong, okay? And that's all right. It's like just making a rough draft or just trying a certain thing to see if it works, but when that happens, a lot of times students get frustrated. I wrote that whole thing down. So you might want to wait to write it down until I have finished the problem to make sure that what we're doing is actually correct, okay? So what I mean by that, when I look at cosine squared minus sine squared, I can either change the cosine squared into 1 minus sine squared from the thing we were doing yesterday, or I can change the sine squared into 1 minus cosine squared, okay? And so I might end up making the wrong choice because sometimes it's not 100% clear which is the best way to go. What I'm going to do though real quick is I'm going to pause the video, I'm going to pause the lesson, and I'm going to pass out your homework from yesterday because you have all these things written down on there and they're very valuable. So give me. All right, so we have two choices here. We can either replace the cosine squared with something or the sine squared with something. Which one do you want to do? You want to replace the cosine squared? I believe that's correct. Is there something in particular that led you to think that? Okay, right, because this is all in terms of sine. So if I can change this cosine into a sine, I'm probably headed the right direction, all right? So to replace the cosine, some of you guys have this in the thing that we did yesterday already. But if cosine squared plus sine squared equals 1, what does cosine squared equal? Good. I can subtract sine squared from both sides, and so that means that cosine squared equals 1 minus sine squared. Okay? That was the things that we did at the very end of the homework yesterday. All right, so I'm going to rewrite this, and instead of writing cosine squared, I'm going to write 1 minus sine squared. Okay? And then what can I do from there? What can I do from there? Yeah, I'm combining like terms. So 1 minus sine squared is really the same as 1 minus 2 sine squared. Yeah, I'm just combining like terms there. Okay, which is what I wanted to come up with, and so I am done. Okay, so that one also didn't take very many steps, but it wasn't as obvious what we were supposed to do. When I put the first one on the board, Danica very quickly recognized that cotangent was cosine over sine, but this one is a little bit sketchier to figure out where we're supposed to go. Okay? No. May I? Okay. All right, so let's go around again. Let's prove that 1 plus cosine of x times 1 minus cosine of x equals sine squared of x is an identity. So when I write this out, and you guys can copy this down as we go if you want, because I know that I'm going to get this one right. I am, yeah. What do I do first? Yeah, do the FOIL thing. Okay, I've got two binomials that I'm multiplying together, so I'm going to FOIL those. So the first thing times the first thing, this times this is 1, yeah, multiplying. Outside times outside is negative cosine x. Inside times inside is positive cosine of x. And then last times last is, what's cosine x times negative cosine x? Multiplying, not adding. Squared, good. Minus cosine squared x. And we want to show that that equals sine squared of x. Okay, so the first thing, yeah. So the first thing we did is we just FOILed. This was first, outside, inside, and then last. And then Austin says that the inside ones can cancel out because one's a negative cosine and one's a positive cosine. So now I have 1 minus cosine squared x equals sine squared x. I want both sides to be the same. Well, once again, let's go back to the one that Janessa was sure to remember. I know that cosine squared plus sine squared tangent. There's no tangent up here. What are you throwing at? But there's no tangent in the problem. What are you throwing a tangent into the work for? You look. How can I take this and do something to make them match? Nope. No. What I'm asking is I'm like one step away here from victory. Good. Okay, good. If I take and subtract cosine squared, I am sorry. I didn't hear you. Okay, so if I subtract cosine squared from both sides, then those cancel. And then that tells me that sine squared of x equals 1 minus cosine squared of x. So I can replace this 1 minus cosine squared of x with the what? Sine squared of x. And then I have this. Wow, tough crowd today. So then I have sine squared of x equals sine squared of x. And so I've done what I was supposed to do. Got both of them on the same side to be the same. Okay? Yeah. Uh-huh. Right. That is such a great question. I wish there was a way that I could like reward you with some extra sort of points or something like that. I don't really have a way to do that, so I'm just going to have to say nice job, Janessa. So Janessa is asking, if I do cosine of x times cosine of x, what I've been writing is cosine squared of x instead of cosine of x squared. And she wants to know why. What the heck? The x is being multiplied too. Okay? In this case, what I would do is I would plug in a value for x and then square it and then figure out what the cosine is. In this case, I would plug in the value of an x, figure out what the cosine is, and then square it. Right, yeah, it's an order of operations thing. So this right here means this, okay? This I would get by going cosine of x times x, like that, okay? On both or something? You could do it that way, yeah. So another way that you would could write that is like that, yep. And that is the same thing, yeah, nice job. Again, I wish there was some sort of extra. I don't know what you're talking about. Yes. Uh-huh. It's called what? Dojo, like a Japanese martial arts center, a dojo. Uh-huh. Okay. Oh, like that. Yeah. Will you give one to Danica also for saying cotangent? No. Really? Really? For what? I can. Okay, so that was a little sketchy. That you guys are saying that was a little bit like, whoa, what just happened? Yeah. Okay, so we're getting worse, not better. How did what? Okay, so you understand how we foiled, right? Okay, and then here I just combined like terms. So since those were the same, but one was positive, one was negative, they cancel. Okay, and then I'm left with 1 minus cosine squared equals sine squared. What I did is I figured out using this stuff here that 1 minus cosine squared is sine squared. So I just replaced this with that, and so then I'm done, because now they're the same. Okay? All right, well, the good news is it only gets more difficult. So let's prove algebraically that cotangent of A plus tangent of A equals cosecant A, secant A. Let's prove those two things are the same. Okay? So what I'm going to do is I'm going to start with cotangent of A plus tangent of A. And this is a really good candidate for don't write this down as I go, because I could make a mistake. I feel like I got this, but I'm not 100% sure. What? Right. Okay, so what we're going to do to start with is we're going to do what Danica said. Cotangent is the same as what? Cotangent is the same as what? Right here. Cosine over sine. Okay? So I'm going to rewrite cotangent of A as cosine of A divided by sine of A. And just in case you're curious, The a variable is completely arbitrary. If you want to put an x in there instead, it's not going to matter. Okay, good. And then tangent is the same as sine over cosine. Okay, they do not cancel because we are adding, not multiplying. If I was multiplying those together, then they would cancel and I'd get 1. But when I'm adding them together, what do I have to do before I can add common denominator? In this case, what will my common denominator be? Sine A cosine A. Good. I have to multiply the denominators together. Okay? So if I started with sine A over here, and I changed it into sine A cosine A, how did I... Right, I multiplied this, good, by cosine A, so I have to multiply the top by cosine also, so that will give me cosine squared, okay? And then the other one is the opposite. I took the cosine and multiplied it by sine, so I have to multiply the top by sine also, so that will give me sine squared, okay? Does that make sense? Okay, good. We're just getting a common denominator between two fractions. So now that I have the common denominator, I can write them as a single fraction.
I'm still confused. Why is it not cosine A squared? And why is it cosine squared A?
Would you feel better about it if I wrote it like this? This is your only other choice. Do you want me to write it like that? No? Okay. All right. So in your notes, just write it like that. And that was what Janessa was asking about. And so if Janessa feels like, yeah, so just write it like that. Okay. What is cosine squared plus sine squared? What is cosine squared plus sine squared? What is it equal? 1. Good. That's the thing I asked you to remember from yesterday. So I'm going to replace that with a 1. Okay. What is 1 over sine of A? When I look up here, what is 1 over sine? Cosecant. What is 1 over cosine of A? If you look up here, secant. And now, ladies and gentlemen, cats and kittens, boys and squirrels, we're done. Because we wanted to show that it was equal to that, and we showed that it was equal to that. Okay? Yep. So we got that one right. So you can go ahead and jot that one down in your notes. And maybe while you're writing it down, you'll be able to sort of go through the steps a little bit and understand what the heck just happened. Okay, last one. Ready? Are you ready? All right. So we want to now show that 1 minus the cosine of b over the sine of b is equal to the sine of b over 1 plus the cosine of b. Okay? And this one we're going to win at, so you can write it down as we go. Any good ideas what to do when you have two fractions that are equal to each other? That's when we're adding or subtracting them. I guess I could get a common denominator. Yeah, you want to do that? Okay. Yeah, no, that's fine. What would our common denominator between these two be? Right, we have to multiply these two denominators together. So this is going to be sine b times 1 plus cosine b. And then that's going to be sine b times 1 plus cosine b. Okay? So, what did I multiply this by? Look at this. 1 plus cosine b. So since I multiplied the top by 1 plus cosine b, since I multiplied the bottom by 1 plus cosine b, that means I've got to multiply the top by 1 plus. Well, we'll deal with that in a second. Okay, so I multiplied the top and the bottom of the left side by 1 plus cosine b. So notice if I canceled the 1 plus cosine b's, I'd be right back where I started. And I don't want to cancel them because I want to get a common denominator on purpose. What did I multiply this one by? Sine. So that means I have to multiply the top by sine also. Right. Okay, so on this side over here, we just did this in a different problem. If I FOIL out 1 minus cosine times 1 plus cosine, what do I get? Nope. 1, because first times first, 1 times 1 is 1. Good, then the inside will give me negative cosine b. The outside would give me positive cosine b. And then if I go last times last, I would get negative cosine squared b. Yep. Okay, so those two cosines cancel out. That's on the bottom. What'd you say? Okay, so that leaves me with 1 minus cosine squared b, and that would be over sine b, sorry, zoned out there for a minute, 1 plus cosine b. Okay, so that's pretty much all we can do on the left-hand side. What can we do on the right-hand side? What's sine of b times sine of b? Sine of b squared. And that's still over sine of b times 1 plus cosine of b. What is something that we know sine squared equals from the Pythagorean theorem or Pythagorean identity that we were doing before? We had sine squared plus cosine squared equals 1. That's the start of everything. How can I solve that for sine squared? Minus cosine squared from both sides, so that shows us that sine squared equals 1 minus cosine squared. So that means I can replace the sine squared with 1 minus cosine squared, and guess what? That means the left and the right are both the same. And so we are done. Okay? Yeah, accidental. Yeah, not very cool. Okay. Holding. Okay. A 100% match. Okay.